Okay, welcome to Electrical Diagnostic Skills and Strategies. My name is Wade McCarty. I'm a service training specialist at Gulf States Toyota. We're the Toyota independent distributor for Toyotas in the 5-state region: Texas, Oklahoma, Louisiana, Arkansas, Mississippi. And we teach all different classes here. I was a technician at a dealership for a number of years and did a lot of electrical diagnosis. And I've been an instructor here with Gulf States Toyota now for a little over 6 years. So today we're going to go through and show you some tools and strategies hopefully you can use in your classroom and help your students diagnose vehicles more efficiently. I know for electrical diagnosis, when you get into that, repairing the part or replacing the part, repairing the wiring, that's the easy part. It's the diagnosis, finding out where it's at. So we'll be going over this and going over some diagnostic strategy, and this will have some good information. On the page there are some handouts. You are welcome to download these handouts, and hopefully you can use them in your training classes. This again is a webinar designed for vocational instructors that teach automotive. So this is one of the worksheets right here. It has a website on it. It's sponsored by Toyota to help with diagnosis. There's a couple of different circuits there, but its website's located right there on this worksheet. And there is a copy of the worksheet on here. And I'll go through and show you how the system operates. And, you know, basically, there's 2 circuits. Normally I present circuit 1. We do it together as class, and then when I give them circuit 2, say, okay, you know how it operates. Here's some worksheets. Go through and test and diagnose where the problem is, where you have an open circuit, short circuit, high resistance, or whatever. So this will allow you to move voltmeters and stuff around virtually and do some testing. Toyota, we use a 6-step diagnostic process. This is very similar to what a lot of other manufacturers use. Again, you got to verify the complaint. You know, does it actually have a problem? Determine related symptoms. I know some people, whenever they're doing electrical diagnosis, first thing to do is check every single fuse in the car. Well, if you study the wiring diagram, the electrical wiring diagram, you can sometimes eliminate that. And that's one of the things we'll use. We'll use some show practice analyzing the symptoms. We have some tools here, allows us to trace the electrical wiring diagram and trace the parts that are good and the parts are bad. So try to isolate it, narrow it down. And then after that, at that point, it's the easy part: repair or replace, and then confirm the repair. This brochure here is also one of the handouts. This is TEX, Technician Education College Support. So the link is down there at the bottom, T10_support@toyota.com. So what you can do with this would allow you to access TIS, Toyota Information System. You would have access through your school, Toyota service information online. Also, the electrical wiring diagrams, electronic wiring diagrams, and there's 6 e-learnings technicians could do. They could go through this, and actually your students could become maintenance certified. One benefit to this, if they decide they want to work at a Toyota dealership, when they go apply, they would already be a maintenance certified and are, you know, for an entry-level position. So that big thing for you as educators, having access to the service manual information. So if you have, you know, Toyotas in your service department or your bays there, that can help, you know, have the correct information, the latest information on. So again, this flyer will be available to you. Okay, this is the website. Again, there is an air conditioning simulator. We're not getting into that today. All we're going to do is the EWD. Okay, I'm going to go get out of the PowerPoint at this point. and I'm going to go to this website here. Okay, so now I'm going to click over here on the right, electrical wiring diagram simulator. And now I'm going to click on circuit 1 here. Yeah. So what we have here is the turn signal and emergency flashers, like on a older Toyota Camry. And the way this thing works is, if you follow my mouse, I'm going to go over here on the left side, upper left. I'm going to click the left turn signal. Now you can see the left turn signal indicators working, the left front or left rear bulbs working, left front bulbs working. Turn that off, turn the right hand on, turn the four-way flashers on. Also notice right above the four-way flashers on the screen is a voltmeter. Click on it, a voltmeter appears. This allows you to test at different points voltage. So I'm going to move this around here. Now, if you noticed, when I put this on the screen here, there's a black dot. Anywhere there's a black dot or a red dot, you can test. If you put it somewhere like this, there's no dots, you're not going to get a reading. So I'm going to put it here for good ground. Now, if I go over like right here, if you look in the left, the voltmeter, it shows 12.6 volts. Put it right here. Now, if you notice, I'm in the middle of the turn signals or the emergency flasher circuit. The voltage is blinking just like the bulbs are. So yeah, you can test different spots like that. Turn it off, and you can test the switches. Right now, it's on bug 0. Bug 0 is default. Everything's working fine. So if they want to go through and show how it works normally, you can see that. Okay, at this point here, I have the left-hand blinker wire going from the flasher to the switch, 12.6 volts. Turn the left-hand blinker on. You can see it goes to 0. So it is a ground control switch. Controls that. Turn it off. Same thing on the right blinker. And the hazard flasher. So when the switch grounds the flasher, it starts working and controls the bulbs. So that's there. We use a product called Epic Pen. There's quite a few annotations you can do on these different electronic surveys, but with this, you can draw, pick colors, and you can trace the power flow. So this allows you to do this. So if you wanted to trace power flow on left-hand blinker, you go over here, start at the battery, positive power is coming up this way to the gauge fuse, over here. Goes to the left blinker, down. And you can have highlighted in red. Now down here at the bottom, you can change colors. Some people like ground and black, some people like green. I'm going to use green for ground. Oops. I accidentally clicked the dot over here. Let me go back to small. Yeah, you can pick the size that you want here. Actually, I want this size. Get my technology straightened here. So you can show them how the circuit's working correctly. So this allows you, oops, I'm not paying attention here. It's actually grounds here. Okay, right there. So you can have them show this is how power flows through the circuit in the left-hand position. So it helps visualize how electricity, because again, you can't see electricity, you can't smell it, but you can measure it with a voltmeter. So this helps to show how the circuit works. Okay, I'm going to go off this now. I'm going to go to bug 1. I'm going to click bug 1 on the simulator right here. And again, first thing you do is verify the complaint. So I click left. With the left turn signal on, we notice nothing is working. Okay, I click the right blinker. The right blinker is working correctly. I click now the four-way flashers, and with the four-way flashers, we can see the right side's working, the left side's not. So at this point, I like to have the technicians trace out. So, okay, what part of the circuit is good and what part is bad? Let's go through and trace out in red where the power, where we know the circuit's good. So the way it's supposed to work here comes up here, again through the hazard fuse, over here, and it's coming down here, and here for power, then green for ground. We know this portion's good, and we know this portion's good. So at this point, we can change colors, and I'm going to go over the portions that's bad. So I'm going to go the positive side and the ground side in yellow, so because it's representing the side that's not working. So the circuit's left-hand side is not working, and it would be possible to have two problems, two bad bulbs or two bad wires or something like that, two bad grounds, but the chances of that are unlikely. More likely, you look for an area of the circuit where one problem would cause both the front light and rear light not to work. So looking at this, looking at the circuit at this point here, studying the electric, you got to point out to your students, studying an electrical diagram. This is a tool, and knowing how to use it can simplify their diagnosis. So by looking at this, most likely spot for one problem to cause both bulbs not to work would be we have connector F1 at the turn signal flasher, pin 3. It's a black wire, goes down to a junction connector on the dash, DD, pin 1. So somewhere between there would be the most likely problem. And we can put our lead up here. And notice we got, with the four-way hazard zone, we got 12.6 volts. Go down here at this point here, we have 0 volts. So looking at this, that would tell us we have an open circuit in this wire that's causing both bulbs not to work. And sort of like sometimes you compare, electricity to water. You pour 12.6 gallons in the pipe, 12.6 gallons should come out. In this case here, we're putting voltage in the top. We got nothing here. It's like it's got a hole in it. So we have an open circuit. Another way to do, some people prefer to do voltage drop instead of available voltage. You could hook here and across here. And in this case here, you can see when the lights are on, the right side's on, we got a 12.6 volts. A good wire should not use any voltage. We can verify that by testing here, do a voltage drop on the good circuit. So you see this wire here is not using any volts. So the loads, again, should use the voltage, not the wires. So again, as long as you have 0.1 volts or less on a wire, voltage drop across the wire, it's typically called a good wire. Same thing on the ground. So that is the one circuit there. So that's bug one. Erase everything here. And let's try another bug. Try bug two. Okay, bug two, same car, left-hand blinker. Okay, left-hand blinker there is, let's see, the front's blinking, the rear is not. Okay, in this case here, both right are blinking. If we go to the hazard flasher, appears just the left blinker is not working. Again, you could have your students trace what's good. So again, on the hazard, it goes through here. It comes over here, down to so at this point there, we know that is good. I'm going to change to yellow to highlight the part that, where's the problem? So the problem has to be somewhere in here. So at this point, we can start doing our testing here. And one of the things I do when I'm teaching class, I have sometimes have the technicians pull up TIS, pull up the electrical wiring diagram. And one of the things under here, they can find connector locations. You know, some connectors are real easy to get to. You just pop a trunk and get right, it's right there. Other connectors buried in the middle of the dash, you got to disassemble the dash to get to it. So that's one of the things I show here. Tell my technicians, try to be lazy. Do the easiest thing first. A lazy electrician, you'll never see him tear the entire dash out of a car and then pop the trunk, find the short in the trunk. Although I do know I've seen a few techs do that, but don't want to do that. You want to do the easiest thing first. So looking here, they could look up and see DD's connector is under the dash. You got to disassemble a couple of panels to it. This connector JC1 is in the left front corner of the trunk. They pull one panel and get to it. And then the left rear turn signal bulb's right there in the rear. Just pop the trunk and the connector is right there on the left side. Easy access. So like one of these things, ask them, where would you start testing? Well, we could go right here, the easiest one first. Got 0 volts. Then go to the next. Okay, notice when we went to JC1, our voltmeter now is flashing basically 12.59 or, you know, back system voltage. So we didn't even have to go under the dash. Sometimes you may have to, but we went to the easy thing first. And this is one of these things as I'm talking to my students in class, I said, okay, try to diagnose it in 3 steps or less. So you can see in this case here, we only moved our voltmeter 2 different spots and basically determined we have an open circuit between JC1 pin 2 and L1 pin 1 at the light bulb. You could also do the voltage drop test again. And you see basically I have 12.6 volts drop across the wire, which indicates an open circuit. So that's one of the things we can do here is use these tools and teach them to use the EWD to study the circuit, and like I said, try to know what a normal is and abnormal. So that was bug 2. And like I said, we have up to 10 different bugs. And let's try bug 3 here. Okay, let's see what situation here. We got, okay, left side's blinking. Right rear's blinking. So the right front bulb is not working. So again, we could do our tracing and see what is working. So again, on this one here, it comes down. This is good. Put a ground in green. And then in yellow, what's not working? Actually, kind of got a little, went overboard with green there. So problem has to be somewhere in this area here. That's not working. So at this point, again, we take our voltmeter. We test that bulb itself, or we could test the connector under the dash. I'm going to start the bulb since it's easier under the hood, easier to get to. Okay, and notice in this case here, we got 12 volts to the bulb. So again, we don't have to get under the dash to check the connector there. Next thing, we go to pin 2, the ground wire. So at this point here, notice we have 12.59 volts on the ground, which means basically we have a bad ground. If we go over here, we have a good ground. We see we got 0. It's not a perfect ground. Perfect would be 0.000. We have 0.1. So as long as you have 0.1 or less, that's a good ground when its circuit's on. So, so we can test here, we can test here, or we can test right down there. There is 2 splices here. We do not have access points. They're inside the harness, so we can't test either place there. So basically, that would tell us we have an open in the ground wire from the connector L4, pin 2, and somewhere in this splice. We know this is good since this bulb's working on the left hand. Since a right hand, left hand share a ground. So you'd have to have an open right there. So that's one of the ways you could diagnose it like that. And again, good ground would be 0 volts. So again, we diagnose it just moving a couple of steps like that. Erase this. Now on the bugs here, I'm going to go to bug 10. We don't have time for all of these today. I'm going to jump to bug 10. And now if you'll notice on this one, we no longer have a voltmeter. We have a headlight. And we don't have the hazard, always got the turn signals. I'm going to turn the left turn signal on. Notice the left bulb's working correctly. Turn them off. Turn the right side on. They don't work. Then I turn the left on. They don't work either. If you notice this point, the gauge fuse here blew. So again, you go back, you're going to show this to your students. Click default status, go back to bug 10, that resets it. So again, Left blinker works. Click the right blinker, gauge fuse number 1 blue, and so now when you go back to left, it's not working. So the headlight, what the headlight allows you to do is plug into the circuit there. So if I turn the right on, it's on bright. Means we got power going through here and we got to short the ground somewhere. Put it on the left. Okay, now it's blinking dim. Notice the left rear is blinking dim and the right front's blinking dim. By having this in here, we have just created a series parallel circuit. So a headlight makes a great diagnostic tool to use for shorts. We've got blown fuse, put this tool in there. And by having that tool in there, you can test for a short and you will not damage any wires. So don't want to put oversized circuit breakers or anything in there to overheat the wiring. So let me give you an example of one of the tools we have here. So, okay, this is a tool we've built here. We just take an old steel beam headlight, some wires. We have this adapter here, a little seat shrink around it. And these are some examples of some of them you can buy. This here is that little bitty mini fuse the newest cars have now, the little bitty tiny fuses, real hard to get any tools in. These little adapters, you can find them different places. But these are very good for making the little test. You can hook up here and you can plug it into the fuse box, the car's fuse box, in place of the fuse for a short tool and not damage the fuse box or anything. Works very well this way. So we go back to this here. So that's what that's representing. This tool here is the short finder. We've used some others, more expensive ones that have circuit breakers on them with a little magnet that looks for the, they switch on and off. Frankly, I have not found those very useful. This here is a cheap tool. Use it correctly, it's very effective, and you're pretty cheap to make. So now at this point, you would start unplugging connectors. When you start unplugging connectors, when you unplug a certain one, if it's after the short to ground, the bulb will remain on. If it's before the short, the bulb will go out. So first place, I'm going to plug right here at F1, right there before the flasher. So now, you look, I've unplugged it right here, the bulb goes out. So that means the wire between the fuse box and the turn flasher is good. It's not shorted to ground because there's no longer a path to ground. Plug that back in. And at this point here, we can continue. So we know it's on the right side. Again, since left side is like that. So we can unplug different places. So unplug here since we're already at the flasher. The bulb goes out. Go connector DD. So that wire is good. Cover this pin here. Bulb stays on. Okay, at this point here, it goes out. That means it after this. Go to junction connector 2, unplug it. Stays on. Again, back here, goes out. So at this point, because again, when we disconnected here, it stayed on. So that means it is between junction connector 2 and junction connector DD, and the green wire has a short to ground. And again, at this point, it's just we have narrowed it down from multiple harnesses in the car to one single harness. Now it's just tracing the harness down, find out where the short is, repairing the wiring, or replacing it. Depends on how badly it's damaged. So that's just efficient test method by unplugging connectors like that. And like I said, you can find a short and you can lay this in the floor, and it's pretty easy to walk around the car, lay it in the, you'll see when you unplug a connector, you'll see the bulb go out. Makes it pretty easy. But where you have a parallel circuit there, multiple bulbs, this works very good for testing like that. Because here you see, sometimes when you unplug one circuit, if half the circuit's still plugged in, the other half is unplugged, all of a sudden the bulb goes dim, those bulbs come on dim, then now you know you just created a series parallel circuit. Again, in a circuit like this, the way the power is flowing, basically you got power coming up like this to the bulb, and then switch to blue now, because at this point here, oh, wrong place. Yeah, it's going up here. So this would be the series portion. So again, this bulb's using part of the voltage, and these other two are using part of the voltage. And then we got the green ground. So again, we have the power part, the series port. We'd have more than 12, but less than, more than 0, but less than 12, where the probably around 5-6 volts where they're dividing the voltage. And then after this, 0 volts on the ground down here. So that we find is a very good short tool there. Okay, so that's one of the circuits there. I'm going to get out of this one just for a second. I'm going to go back to circuit 2 and click on circuit 2. Now on circuit 2, this represents the park light circuits, tail light circuits, and the stoplight circuits. And again, we have the voltmeter here. So default status, again, everything's working normal. Same thing, you can check voltage here. Again, anywhere there's good ground, you can check 12.56 volts. So turn them off on. So let's try a bug here on this one here. Try a fun one. I'm going to go down to bug number 9. Okay, bug 9. See, I'm going to turn the park lights, tail lights on. Okay, park lights, tail lights seem to be working. Turn them off. Turn the stop lights on. It's kind of unusual. We now have turned the brake lights on, and the high center, high mount stop light's working. The right side stop light bulb's working. The left side stop light bulb's not working, but notice the park light and tail light, and even the front marker park lights, they're on dim. What happens if we turn the stop lights and the park lights, tail lights on? Now the left side goes out, and all the others are working as, so left side tail lamp and stop lamp are not working, side marker. So as a technician, when I was working in a shop, I actually had worked on several cars with this exact problem. And a lot of times we call this sort of a feedback issue. But if when you go over as you're covering, basic diagnosis of electrical voltmeter, normally, you go over voltage drop, and tell them you check for available voltage, and you check to verify it has a good ground. Good ground, again, 0.1 volts or less. So at this point here, we could test 12.54 volts on the stop lamp circuit, 12.56 on the tail lamp, 12.56 on the side marker. All three bulbs share a common ground and go down here. Okay, we got 12 volts, 12.58 volts on the ground. I'm going to go right down here. 0.1, so I have a good ground. So that tells us basically we got a source voltage drop across the ground, got an open ground. So we repair the ground, the system should start working normally. But sometimes when technicians get like, okay, when you have the stoplights only on, how did the tail lights come on? And again, this is where if you use something that you can put annotations or highlight something, you can trace out how the power goes. So again, stoplight fuse, power's going to come down here, down like this, down here, and it also goes here. Now at this point, it can't go down to ground because the ground is open, but we still have potential. We got electrical pressure, so it's going to go down through this bulb here. Since it's a dual filament bulb, it can't go to ground, it goes over, and it feeds back into the tail light circuit up to the junction connector right here. Junction connector, it ties all the other bulbs together. So it comes down here, over here, across here, goes back up this way. And we have our ground. Again, I'm using green for ground. So I'm just putting in the green for the grounds we know are good. So that's how you would have the circuit would work. So how you have created a series circuit and the bulbs are dividing the voltages. So I've actually worked on several cars and pickups and stuff like this. A lot of them when the owner had put their own trailer light wires in there and cut the ground for one side or the other. So this helps to demonstrate how current flows and how you can get a feedback by a ground. So bad ground can create a feedback. One circuit feeds into another circuit. And so you step on the stop lights and the park lights come on. I've even seen the, stuff like that. The dash lights come on since they're tied into the park lights many times. So that's an example of some of the different things we can do with this. And main thing on this is you're trying to get them used to using an EWD, electrical wiring diagram, understand how it works. And again, going back over here to the default status. Again, this here, at this they can test everything to see how it operates normally. Again, the headlight switch here, park lights, we see you got 12.6 volts going to the body ECU, main body ECU, and then we turn it on. You can actually see the tail light relay. If you notice right here in the middle of this gray box where it says tail light relay, the contacts in the relay, there they're open, there they're closed. So again, when you off, you'll have 12 volts to the headlight switch for the tail part. And when it grounds this wire, then the main body ECU turns the tail light relay on. And again, power would come like this, go down here. So doing stuff like that allows them to test and show them how ground side switching, you can have power side switching in the case here. Oops, let me back here. Move the voltmeter over here. You see you got 12 volts here. I'm gonna turn this stoplights off. We got 12 volts to the switch, 0 volts after the switch, 12 volts when it's on. So they can show them you got power side switching, manual ground side switching. So there's some of the different ways you can work. So hopefully this would help them be able to use a electrical wiring diagram, diagnose electrical problems easier. And like I said, going through the text program, having access to the electrical wiring diagrams, EWDs, as we call them. Yeah, you can improve your diagnostic skills and stuff like this. And hopefully this would help you teach your technicians good ways to diagnose, because that's what, electrical diagnosis is a big thing. Knowing where's the bad wire, where's the bad part, how a circuit works normally. So, okay, at this point, I think we're gonna open up for some questions. Let Dave start taking questions. You got any questions for me, Dave?
Yeah, I believe we do, Wade. Well, first of all, I just wanted to say we've gotten a lot of comments, positive comments about what this illustrates in this tools and what a great, teaching aid it really is. So first of all, I want to mention that. And what I'm going to do now is I'm going to go over to Dan Baumhart. And Dan, what do we got cooking over in the questions pane?
Thanks, Dave. So John asks, as well as Roxanne and several other people, about the software again that you were using, and that if you could repeat if instructors can have access and how they can get it. Okay,
are you talking the program here that we use is ITP-training, and it's a website sponsored by Toyota, and it has these two diagrams on it you can use for electrical diagnosis. That's pretty much free to open to anybody. If you want to get into, there's that one flyer you can download for text, again through Toyota sponsorship through the T10. They will allow you vocational colleges and stuff access to Toyota information systems, and by doing that you can get your students SPIN numbers, and they can go online and take some online e-learning from Toyota. And they also have access to TIS, Toyota Information Systems, which is basically our online service manuals. So they have a service manual access right that away through this program. Yeah.
Okay, that should help a ton. Shane, that should get you set too. Jason asks if you can adjust the DMM settings to such as ohm or volts. Is that possible in there?
On this simulation, no. It's pretty much just volts only. There's no ohms or amps or anything like this. It's just pretty much volts on this one.
All right, and then Christian asked about the fault on bug 3, if that was high resistance. Is it possible? I asked him which scenario it was because I was typing answers, so I couldn't follow, but there was no response back from him. So I don't know if you can go back to maybe a fault 3. And then in there at the same time, Craig asked if you could show the menu on the lower right to allow, that was, Craig was asking about the tracing tool, if you could show that menu again.
Okay, the tracing tool I have right here is one we've downloaded called Epic Pen. It's available. You can search for Epic Pen. That's one we've used. It works on multiple programs like this. There's several programs also have built-in, Zoom and some of these others have built-in annotations on it. I was talking to Dave here earlier. This program has some annotations built into it. I had never really used this webinar program before, but it actually has some similar things where you can get a pen and you can do similar things like that. And you can change colors, stuff like that. It has a spotlight feature. You can go in spotlight, stuff like that. But with the pen, you go in and say, yeah, the problem's right there, or not that familiar with this one here. It's got a highlighter. You can highlight circuit. So again, there's several out on the market. We're not trying to endorse one product. It's just one product we found that we like, that we did use.
Okay, then bug number 3. Is it possible to do that one again?
Yeah. Okay, on bug number 3, let's see, we have okay, on this one here, we have again, these lights here are blinking. The turn signal lamp front right hand is not working. So we know all this is good. So that means somewhere over here, the problem has to be on this side over here. It's got to be somewhere down in this right here. So again, we can do a voltage test on it. Again, available voltage where you put your black lead at a good ground and move your red lead around at different points to test. So again, at this point here, since this is working, the rear, we know it's good there, so 12 volts. So we have 12.59 volts here on the green wire, the top of the green wire, pin 6 DD, go to the bottom of the wire, pin 1 L4. We have 12.59 volts. And then here we have 12.59 volts. And that would be an open circuit. If it was high resistance, you could have a corroded ground or something like that causing this issue. Now, corroded ground would be something more like 4, 5, 6, 8 volts, 9 volts. I have seen that. Sometimes it's like 9 or 10 volts. The bulb's not on, or maybe it's extremely dim. That would be high resistance, and the voltage would be divided between the bulb, which is the load, and the resistance in the ground or wiring or whatever the connection. So yes, but being that we have full source voltage, we're getting 12.59 volts there. Same voltage we're getting on the other side, so we're getting source voltage on the ground. That would be completely open. But yeah, if we had like 12.2, they could have very high resistance. But 8 volts, 9 volts, whatever would be high resistance on that ground circuit. Okay, is there any other questions?
Yes, can you run back, Wade, to the headlight trick and do that one over again?
Okay.
And while you're flipping back there, the training website for the training is in the handouts. That information is in the handouts.
Yeah, that one worksheet I went over the first, itp-training.com, that is on that handout. It's got the blue link on it. So yes, they should be able to access that. Okay, the headlight here, like I said, we turn the right hand blinker on, the fuse blows, so we can go in right there and put the headlight in. When it comes on, we know we got to short to ground because it's on full power. Turn right off, turn the left on. Pardon me. At this point, you can see the left the headlights blinking dim. Also, the left side of the lights are blinking dim because we've created a series parallel circuit. And this is what's so great about that circuit, especially on a bulb circuit or something like that. You would start unplugging connectors, you got a bright bulb, and all of a sudden the bulb goes dim and the bulb at the front comes on. The one on the front's out, you know the short's somewhere up front. Makes a very effective, simple diagnostic tool for shorts to ground, and you will not overheat wires, you will not damage the wiring. That's been so many times I've seen guys start, using stuff in there, keep putting larger and larger fuses. Well, they put a fuse in there, it can handle more current than the wiring and melt the wiring. So that's not a good thing at that point. Is there any other specific questions on this circuit?
Well, while you're there, Ruben asks, do the students get a customer concern with each of the bugs?
We normally at this point just tell them, hey, we'll see. The customer says the lights aren't working right. So, and first thing to do, that's where we talk about, you have great service advisors. They'll write it up as right front bulb doesn't work. And then you got other service advisors say check lights. You get the ones like that, the best thing to do is check everything, see if everything works. So that's what we tell them. You have to allow the service advisor. Check everything. And verify everything works. So that's normally the way I handle that.
Can you jump back, Wade, to the headlight test kit you showed earlier?
Okay.
They're also interested in the CT6100. Yeah.
Yeah, that we got through Amazon. Bobby bought it through Amazon. And we were looking, we'd made our own connectors, and we were like, we got to come up with something better to, that we can put in place, because we made our own connectors. When we had larger fuses on the older cars, it wasn't too hard to make your own test leads. And then when we started getting the little bitty mini fuses, that's when, we decided, we need a better tool. And like I said, these mini fuses right there, so by making it one like that, and this is, like I said, Bobby found this online. He bought a few, and we've been using them since. So I think this tool here in the picture, we've been using it 5-6 years, and it's worked fine with no problem. And we do just pass this around in class and say, hey, you want to make an easy lead? That tool right there.
Hey, Wade, can I interject something here?
Yes.
Okay, so this is Bobby Willis, by the way, guys. Be careful whenever you build this apparatus. Number one, make sure that you use a sealed beam headlight. If you happen to have one of the old halogen bulbs laying around in your toolbox, do not get caught in the trap of trying to use it. Number one, it creates way too much heat and you will damage the interior of the vehicle. The sealed beam is large enough and it has enough insulating material that it can stay active for quite a period of time before you have to worry about any type of heat damage from the lamp itself. Now, the CT6100, the devices that he's talking about there, they actually now have an updated version of that same unit. It now comes with 5 of the fuse adapters instead of the 3. It also has now the mini fuse along with the side terminal fuse adapters also. And all you do is build your headlamp assembly with the lights on it, or with the wiring on it like you see there. Instead of at the adapter end, you just use female spade connectors at that end, and that allows you to change the adapter depending on what style of fuse you actually have to work through your problem with. So just want to give a little information so that somebody doesn't accidentally get in there and damage a vehicle. So great job.
Okay, do we have any more questions?
think you've covered pretty much all of what has come in the questions pane. Again, so for those of you that have popped in late, the handouts and the materials are in support of this presentation. They're available in the downloads pane. Kick in there real quick and grab them. Again, I'm going to pass this over to Dave.
All right, Dan, thanks for managing that. And thanks everyone for attending this session. I think this really showed a great way to illustrate electrical problems and ways to track them down. So without further ado, we're going to go ahead and wrap this up. So on behalf of Wade McCarty, Bobby Willis, Dave Kappert, and Dan Baumhart, and for the ASE Education Foundation, thanks everyone for attending, and we'll see you at another webinar soon. Have a good one, everyone.
Have a great day. Thank you.
Thank you.